أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. I welcome you all in our today's online session. Hope you all are fine and having good health. We start today's session with the verse of Holy Quran. Further, we start today's session of lecture number 3 of probability. And in this lecture, we discuss the use of statistical analysis in engineering and in technology, that what kind of vital role plays of statistical analysis in engineering and technological fields of different aspects, which applied in different domain. So we start the aspects, the use of statistical analysis in engineering and technology, that is statistical analysis in which the data we we got by the provided format or unformatted data. So statistical analysis is a collection of method used to gather, organize, analyze, interpret, present data in engineering and technology. It helps professional make informed decisions. So first we need to collect the data and analyze to form a decision and to concise our rules, regulations to make a decision for any aspect in the real world and in different scenarios that improve system performance and ensure quality and reliability. So these are the aspects in which the statistical analysis plays a vital role. Further, the quality and assurance. Statistical techniques are widely used to monitor and maintain product quality during manufacturing process. And which kind of manufacturing process need to discuss that control charts for process, monitoring, acceptance, simple sampling of for inspection, Six Sigma quality improvement programs. So these are the quality control assurance program in which the statistical data matters a lot. So what are the benefits which we need to discuss? That reduce defects, improve product consistency, minimizes production cost. So these are the benefits of the quality assurance applicability of the statistical analysis in different fields. So coming towards the next aspect of the application of a statistical analysis, that is in the field of engineering and technology, that is design and development. Engineers use statistical data to evaluate design alternatives and optimize system performance. For sake of simplicity, the design for experiments, respond surface methodology, sensitivity analysis. So these are the further examples of a statistical analysis in the optimizing performance of different models in which the statistical analysis used in engineering and technological fields. And what are their benefits? That improve efficiency, reduce development time, optimizes resources utilization. So if we utilize the resources in vast variety aspects and need to reduce or optimize, which can cut down the cost and optimize way. So we need to optimize the resources that utilizes in different aspects. So further, the third application of a statistical analysis in engineering and technology is reliability and maintenance engineering. So statistical methods help predict equipment failures and determine maintenance schedules. So the data provide the scheduling, and by this schedule way we can manage the maintenance for the equipment pathways. Examples for this scenario is reliability analysis, failure rate estimation, and variable distribution analysis. So these are the ways in which it applicable. And what are their benefits are the increases in equipment lifespan, reduces downtime, enhances system reliability. So the fourth aspect is the processes optimization. That is, engineers analyze process data to identify variations and improve operational efficiency. Examples for this aspect is regression analysis, in which we have different aspects of data in a single domain or two domain, in which the data is mapped on a graph, and we need to get the data in single approximate and inline arrange to the curve or straight line. So this is the regression analysis, in which we got the data pattern, and in depth we need to concise that data into a single line applicability. Process applicability studies, the second one is, and further statistical process control. Benefits for this improves productivity, reduces waste, enhances process stability. Further research and innovation, that statistical analysis is essential for validating experimental results and technological innovations. For the example are hypothesis testing, analysis of variance, and the correlation analysis. In correlation, we have uh, to comparison of data from one to the another, and it have the two types, that self correlation and other correlation, that is also called the cross correlation. Self correlation, the data compare by itself, and cross correlation, the one data is compared with another. So correlation is the comparison of the data. That analysis mostly used in different aspects. Benefits, which are supports scientific decision making, validates research findings, identifies meaning trends. Further, coming towards the sixth application of statistical data, that is the risk assessment and decision making. This is the most important aspect in most of the scenarios, field of engineering technology. Engineers use probability and statistics to evaluate uncertainties and risk, and it is also called the risk management. For the example, risk analysis, Monte Carlo simulation, probability distributions. For the benefits, improve safety, support strategic planning, reduces uncertainty. Coming toward the seventh application, that is application in modern technology. Statistical analysis plays a crucial role in emerging technologies such as artificial intelligence, machine learning, robotics, Internet of Things, data analytics, telecommunication. So these technologies rely on statistical models for prediction, classification, optimization, and pattern recognition. So by which way we can improve our models, improve our scheduling, maintain the reliability of system, and optimize the cost estimation further. At the end, the conclusion of this topic is statistical analysis is an in indispensable tool in engineering and technology. It enables engineers to make data-driven decisions, improve quality, optimize processes, assess risks, and develop reliable and innovative technological solutions. Its application enhances efficiency, productivity, and all over the system performance across various engineering disciplines, in which the electrical, mechanical, mechatronics, aviation, and the automotive, civil structural engineering, designing applications, computer science, biomedical statistical analysis, and all these kind of aspects are touched by the statistical analysis. So, further, this is the summary and the conclusion regarding this topic. Further, we coming towards the most another aspects of the use of central tendency, and these central tendency are relevant with we call mod, mean, and median. In mod, mean, and median, what are their applications and applicability, which we also call the central tendency. So this is the central tendency aspect of mod, mean, median. So mod, mean, median are measure of central tendency used to minimize and analyze data in engineering, technology, business, and research. And further, the applications of this aspect are: number one is arithmetic mean, which we also call mean, and another name is average, arithmetic average. So these are 4 or 5 names which have the single meaning, which we in short called mean. The mean or average represent the average value of data set, and it is used when all observations are important. If we need to include all the observations and take the average of that value, it is called the mean value. So what are the applications of that mean? Determine the average output of manufacturing process, that how much the average we got from manufacturing process. Calculating average power consumption in electrical system. So average power is the most important aspect in which we concise and conclude the utilization of power in different aspects. Finding the average marks of a student in class, estimation average traffic flow in communication networks, analyzing average sales, profits, and production rates. Further, the average voltage measured from several readings in an electrical circuit can be determined using the mean. Further, the second application of central tendency, it is we call the median. Applications of median is the median is the middle value of an order data set. If we need to got the middle value of it in data set, we need to use the median. But we have the difficulty that the data is group and in group the data is even in odd. So we need to find different aspects for this. It is useful when the data contain extreme values, outliers. So the number of data we got in different aspects, and we need to find its middle value. Applications for that: analyzing household income distribution, determining the typical response time of the computer network, evaluating property prices in a region, measuring the central tendency of skewed engineering data, assessing median lifetime of electronic components. So electronic devices have this kind of difficulty as well. Further, the example in the data set containing very high and very low salaries, the median provides a better representation of the typical salary than the mean. Application of mod, coming towards the third topic, that the mod is the value that occurs most frequently in a data set. And what are their applications? That identifying the most common product defect in manufacturing, determining the most frequently used in machine setting, finding the most popular product size or color, analyzing the most common failure type in maintenance records, market research to determine customer preferences. So these are the applications of mod. Coming to the example, a factory may use the mod to identify the most frequently occurred defect and take corrective actions. For this sake of simplicity, we need the standard tendency of mod. So mod provide this in a convenient way. Further, coming towards the comparison of this aspect, so it's the kind of data in major definition best used when an example or application. So as per the three types of standard tendency, that is mean, median, and mode. The mean is the provide the average of all values and the best use of when data are evenly distributed. An example application, average production rate. And what are the median? Middle value of the data we call median. Data contains outliers. Example application, median household income. And coming toward the mode, that is definition based, most frequent value. Best use when identifying common occurrence, and the example application, most common product defects. So these are the applications commonly used in different aspects of fields. So coming towards the third topic, that what are the mean? Mean is the simple aspect that how can we find the mean or average value of the data? First, we need to get the data, arrange sum of all values divided by the total number of values. We got the value of mean and average. We all know this simple aspects. So that's a simplicity. I'm not going to solve this average value, and that is called the mean. But if we coming towards another aspect, that is median. Ungrouped data, as mentioned, this is the data which is in different arrangement, and we need to find the median of this ungrouped data. Ungrouped data means in which the interval of the data cannot mention. The data is in digit mention, but not in interval that have starting and ending value. If data is not arranged in this format, so this kind of data we call ungrouped data. So steps of this solution is, first we need to arrange that data, that starting small values first and then higher values in last. So after that, we need to arrange in ascending order in second step, and number of observations are 15. Total number of digits are 15. So 15 is the odd number, not even. So odd number have to find the median, that n plus 1 divided by 2. This is the step which we need to find, which we need to follow and find the middle value. So 15 plus 1 divide by 2, we got the value 8. And in sequence of 8, 1, 2, 3, 4, 5, 6, 7, 8, that is 23. The 8 value is 23rd value. So this is the way that how we need to find the data median value from the data. Coming toward the fourth topic of this aspect, that is find the mean of ungrouped data. As mentioned, this is another data which is arranged over here, and we need to find the mean of this data. So how that we find the mean? Coming towards the solution of this question, For mean, first we got the data, add all these values, and we got 49. The number of values are 10 in quantity. Sum of all values as 49 divided by 10, we got 4.9. So average of this data is 4.9. So this is the way that how we can find the data mean. So at the sake of simplicity, we got the value. So this is the way that how can we find the mean value from this kind of data. Any one of you, if have any kind of question or query regarding these four topics, you may ask. I will answer the kind of question and resolve your queries. In this lecture of lecture number 3, we got the four questions. Two is theoretical side, and another two are in numerical base calculation. So I will share this lecture at your group, and further, hopefully there is no kind of question query at your end. If you have any kind of question or query regarding the question, I will answer the kind of question and resolve your queries if you have in your mind.